visualize it better, I'll mention the fact that when you go to the mall, and most kids have gone to the mall, you see the big expansive parking lot, and typically you'll see some ponds all around it. What do you think those ponds are for? I'll talk about those are actually detention ponds. So all the water from the parking lot is going into there, and we'll see if that's going to work. So then we're going to run the same experiment. So we got 2,200 milliliters. So we'll just keep the same because has everybody had a chance? I think everybody has. So we'll just keep the same group. We'll do the same thing. So let's get our first reading. We're going to run the same experiment now with this setup and with a retention-detention pond.
Are you on the computer? He's just getting set up probably.
Yeah, see if you have internet access.
5.02.
He just has to pull
5.02.
up the Excel spreadsheet for a minute.
Oh, okay.
We need to get back
Just
to
for
that
a minute.
spreadsheet.
Okay. So he's with OPP, who is the company that helped us
Is that it?
get.
Oh, you could jump.
There you go. There you go. That is
So
it.
we can actually fill
You
in
take the reading.
You just go
Hey,
back
Darren.
up there, buddy.
All right.
Nice to meet you.
So anyway, so we need somebody to archive the data. So who's gonna jump back there?
You want to do it?
I mean,
I'll do it.
Okay.
That'll be the rain.
So the first reading was what?
502.
Go ahead.
5.02.
Oh, you have?
Mark, our first reading is 5.02.
Bob pointed to Dave. I said that as a joke, and she didn't know what I was talking about. I said, being a rainmaker, you know, you saw you talking to be a rainmaker. And she didn't even, that must not be used.
Yep,
That must not
okay.
be a common,
And then the question is,
an expression.
how many think it's going to flood
Like bringing in this,
and how many don't? So that's your discussion point there, as whether it's going to flood or not.
must not be her comment.
And so we're going to see if that is a reality. So our rainmaker and our timer, let's go ahead and get started.
Tell me when
We
to
got our
start.
initial reading. We got a timer?
Who's the timer?
Okay, we're
Start.
going. Got our bucket? We're good?
Time.
Same.
Go.
Same.
Go.
Same.
Go.
5.03.
Go.
5.04.
Go.
5.04.
Got a little hydraulic jump there.
Go.
5.05.
Impressive. And the pond's still peeing.
Go.
5.06.
But yeah, there's, we definitely have
Go.
5.06.
Go.
5.06.
Go.
5.06.
Okay, so we can pretty much stop it here. So that this is just going to go on ad nauseum. But the point is for the students is they can see right away there are some other techniques that are less evasive than a levee that maybe can mitigate. And it gets back to Jim's comment, which I think is so valid, is how do we attack this problem a piece at a time? It's like chewing an elephant. You got to just take one bite at a time. You can't eat the whole elephant. So if we dabble in every little bit, so if every community, every parking lot, every house, everybody deals with their own runoff footprint, then we can get a handle on the situation. So that's kind of a cool thing with this parking lot, so that, and with the retention pond, so they can see that design criteria. And then for the older kids, you can talk about how do we design these things? How big is the orifice? And then the other question is, if we do this times 100, what does that mean? Because you have to count for the accumulating effects. So if everybody's doing this, yeah, it's a good idea, but sooner or later it's going to add up to where you're going to have flooding again, right? So you get them thinking about those kind of issues. So you can bring all kinds of different issues into play, depending on the sophistication of the kids you're dealing with, to get them thinking about all these issues and how complicated it is. But the cool thing for me is you get them thinking about all these career paths that they may haven't thought about. So engineering and floodplain management, emergency management, Corps of Engineers, Weather Service, whatever it is, it's really kind of a neat field to be in because you're doing applied science and you're really trying to solve world problems and stuff that they can relate to. So if they've been flooded, they can see the issues here. So that's really the experiments that I run through during a class period. And if you do it fairly efficiently, you can get through in a 45-minute time period. And then what we want to do next is look at the curves. So the cool thing with the curves is you can clearly see that when we had the wetland is at that lower blue one, so we had our lowest flow there and our lowest peak, and then all of a sudden we urbanized everything and the peak just rapidly ratcheted up. And the interesting thing here is, which kind of surprised me, is usually what happens is the red one, which is the one without the levee, ratchets it up. But when you add the levee, the green one, typically that goes up even higher and faster, which makes sense because now you're channelizing the river. So we didn't quite get that result, but we still got a real high peak on it. a little bit higher than the other peak, but the timing kind of surprised me a little bit, and that could be a function of just how it was poured in. But oftentimes, what I expect to see is the fact that that will be a higher crest and it'll be a quicker crest, which would make sense because you're channelizing the river. So that's what you would hopefully see in a perfect world. And then you get to the final one where you've got your retention detention pond, and you can see how you've dampened out that floodway. So once again, from a student's perspective, it's no smoke and mirrors. We're putting in the same amount of water in the same watershed. The only thing that's changing is our watershed itself. And that's really the concept that I want to get across is, you got to think on a watershed systematic approach. It's not just the poor schmucks along the river. It's not their problem. It's everybody that's in that bathtub, that's in that watershed, contributes to that problem and has to solve the problem. So that's kind of the neat takeaway, is to deal with that. And then if you want to do other experiments, and like dams were recommended, and I've done that before. I usually will build a dam up in here to have this type of constriction up here to see if that's going to work. Of course, you can have that fail. The other thing that for the storm